right, so this is going to be a video about Rolle's theorem, and if you know anything about me, you know I love Rolle's theorem. Okay, so the problem states, find the values of c, if any, that are guaranteed by Rolle's theorem for the function f of x equals negative x squared plus 6x on the interval from 0 to 6. So the first thing I'm going to do is I'm going to write down that function. So we have f of x is equal to negative x squared plus 6 and plus 6x, and then I'm going to write down the interval, which is from 0 to 6. Okay, step one whenever you're doing these problems is you want to make sure that Rolle's theorem applies. If it does not apply, then you cannot do the problem. So first thing you want to do is check that it is continuous on this interval. So if you look at this function right here, you should be able to tell that it is continuous on this interval. If not, then you need to graph it on your graphing calculator. I'm going to show you that in a little bit. Next, you need to make sure that it is differentiable in this interval. So if you see this right here, the derivative of this would be linear, and it is differentiable everywhere on this interval. Then you have to check and make sure that the endpoints have the same y value. So if you plug in 0 here, what do you get for y? Well, if you plug in 0, you get 0. If you plug in 6, you get 0 as well. So they do have the same y endpoints, so Rolle's theorem does apply for this specific example. All right, so this is going to be how to use your calculator to prove that Rolle's theorem does actually apply. So the first thing that you're going to want to do is graph the function that is given for that certain problem. So this specific problem, it's going to be negative x squared plus 6x. So you put that in your y1. Next, you're going to want to hit the window button, and you're going to want to change your x-min and x-max to be whatever the x-min and x-max is for the interval for the problem. In this case, it's going to be 0 and 6. So I'm going to press 0, enter, and then I'm going to press 6 and enter. Okay, now we want the screen to zoom fit around that function on that interval. So a good idea is to hit zoom, and then you're going to want to hit zoom fit, which is zoom 0. So hit zoom, and then hit 0, and then it's going to graph the function on your screen just like this, and then you can see, okay, is it continuous on this interval? Yes. Is it differentiable on this interval? Yes. Is the endpoints have the same y values? In this case, yes. So Rolle's theorem does apply, and you can actually kind of see exactly where it does apply. You can see the derivative right here is equal to 0. Okay, it's also equal to 0 at x is equal to 1, 2, and 3. So when we do the math right after this, me showing you this graph, it should work out to be x is equal to 3. So hopefully it does. So this is how to show Rolle's theorem does apply on your calculator. That being said, if Rolle's theorem applies, it says to figure out the value of c,